Now that you have learned to create basic pivot tables, grouping by single fields like districts or season, we are ready to go deeper with multi-level grouping, filtering for specific insights and avoiding a common calculation error. These advanced techniques turn pivot tables into powerful decision-making tools. Let's start with multi-level grouping. To answer, which districts received funding in which seasons? This reveals seasonal patterns by location. Create a new pivot table. Insert pivot table, new worksheet, OK. Now drag tender district to rows. Districts appear. Here's the key, drag season also to the rows area. Below, tender district. Watch what happens. Season now nest under district. Anugul expands to show monsoon, post-monsoon, pre-monsoon sub-rows. Same for Kalahandi and Khorda. Now drag awarded value to values. The pivot table shows total funding by district and breaks it down by season within each district. This reveals patterns. Kalahandi received most funding in the monsoon season, about 11 crore 7 lakhs for repairs. Anugul's funding was split across season. This multi-level view helps district collectors plan which districts need post-monsoon repair funding versus pre-monsoon preparedness funding. Now, let's filter to focus on specific data. Suppose district collectors want to see only post-monsoon funding, the repair phase after flooding. Drag season from rows up to the filter area's field list. A filter drop-down appears above the pivot table. Click it, uncheck select all, and then check only post-monsoon. Click OK. The pivot table updates, now showing only post-monsoon funding by district. Kalahandi 7 crore 90 lakh, Anugul 2 crore 97 lakh, Khorda 1 crore 4 lakh. This focused view answers which district need the most post-monsoon repair support, thus allowing you to create clear actionable insight for emergency response planning. Now, let's look at an error. Average when you need sum. Remove the season filter, click the filter drop-down and select all. Now, let's see what happens with the wrong calculation. Right-click Sum of awarded value in the pivot table, choose Value field settings, change from sum to average, click OK. Look at the results. Numbers dropped dramatically. Kalahandi shows 80 lakh instead of 20 crore 19 lakh. Why? Because the average divides total funding by the number of projects. Average tells you the typical project size, not total investment. Use average when asking how much per project. Use sum when asking how much total. For funding allocation decisions, you must always need sum. Be careful which aggregation you choose. It completely changes your conclusions. Let us fix this. Right-click again, Value field settings, change back to sum, click OK. Now, let's add a useful insight using average correctly. Create a new pivot table, drag tender_district to rows and awarded value to values. By default, it shows sum, total funding per district. Now, drag awarded value to values again. It appears a second time. Right-click this, second, sum of awarded value. Choose Value field settings. Change to average. Click OK. Now you have both total funding and average project size per district. Kalahandi has high total funding but also high average project size, about 80 lakh per project. They are doing fewer larger strategic projects. Khorda has a lower average, about 13 lakh per project, than smaller interventions. This reveals different approaches to flood preparedness. I hope this helped you understand how to use multi-level grouping to see patterns within groups, filtering to focus on specific scenarios, and choosing the right aggregation function. The only way to actually learn to do this is by practicing this yourself. I hope you can see the value of pivot tables as decision-making tools. Aisha can now tell district collectors Kalahandi needs significant post-monsoon repair funding. Their strategy focuses on fewer, larger projects. Khoda takes a different approach with smaller interventions. Ready to use data analysis for decision making? It's time to practice.